That sentence should stop you cold. Because everything running, your phone, your car, your hospital, your bank, traces back to a 36,000 square kilometer island in the Pacific that is quietly running out of the one resource its entire industrial civilization depends on. And the mainstream conversation about semiconductors, about supply chains, about the next tech war between Washington and Beijing, almost none of it mentions this. Almost none of it tells you that the factories producing the chips that run the modern world require an almost incomprehensible amount of ultra-pure water every single day, and that Taiwan's reservoirs have, in recent years, dropped to levels that force the government to cut agricultural water entirely and ration industrial supply in ways that the industry has never publicly quantified for the people whose lives depend on its output. Here's what this means for you. The laptop you're using, the car you're driving, if it was made after 2018, the medical device keeping someone in your family alive, all of it depends on a production process that is one sustained drought away from serious disruption. And the price you'll pay at the register for every electronic device over the next 2 years has already been partially calculated by the water levels in reservoirs you've never heard of. This channel doesn't run on corporate advertising pressure, doesn't take government money, and doesn't have an editor telling us which parts of the story to leave out. If you want analysis that goes where the mainstream technology press refuses to go, the uncomfortable intersections of climate, geopolitics, and industrial fragility, subscribe now and turn on notifications. Because this story is just getting started. Let's build this from the ground up. Taiwan Semiconductor Manufacturing Company, TSMC, produces approximately 92% of the world's most advanced chips. Not 50%, not 60%. 92. The next most advanced manufacturer, Samsung, produces the remainder. Every other player in the global semiconductor market is years, potentially decades, behind the process nodes that TSMC currently operates at its fabs in Hsinchu, Taichung, and Tainan. When you hear 3-nanometer chip or 2-nanometer process, the technology inside the iPhone 16, inside NVIDIA's latest AI accelerators, inside the processors powering the data centers running the artificial intelligence revolution, that is TSMC. There is no substitute. There is no backup. There is no Plan B currently operational at industrial scale anywhere on Earth. Now here's what the coverage of TSMC almost never discusses. A single TSMC fabrication plant, one fab, uses between 150,000 and 200,000 tons of ultra-pure water every single day. Not regular water, ultra-pure water, processed to a standard so precise that a single contaminant particle per trillion can destroy an entire production batch. The purification process itself is energy-intensive, chemically complex, and requires a continuous, uninterrupted supply of source water that meets baseline quality thresholds before purification even begins. TSMC's facilities collectively consume water at a scale comparable to a mid-sized city, and they operate in a subtropical island environment where rainfall, historically generous, has become dramatically less predictable. The official story from TSMC's public relations department is reassuring. The company has invested in water recycling, it has built desalination capacity, it has reduced water intensity per chip produced, and all of that is true. Here's what the official story leaves out. In 2021, Taiwan experienced its worst drought in 56 years. The Baoshan Second Reservoir, which supplies a significant portion of water to the Hsinchu Science Park, the geographic heart of Taiwan's semiconductor industry, dropped to 3% capacity. 3%. The government suspended agricultural water allocations across large sections of the island for the first time in living memory and trucked water to industrial zones to prevent production shutdowns. TSMC maintained output through a combination of emergency reserves, accelerated water recycling, and what the company described as operational adjustments, a phrase that, in manufacturing terms, is a polite way of describing production prioritization, which is itself a polite way of saying that not everything scheduled gets made. The market felt it. Global chip shortages that began in 2020 and cascaded through 2021 and 2022, costing the automotive industry alone an estimated $210 billion in lost revenue, had multiple causes: COVID-related demand surges, logistics failures, factory shutdowns from the pandemic itself. But underneath all of it, running as a quiet current through every analyst briefing that didn't make the front page, was water. Taiwan's water. The physical substance without which the digital infrastructure of the 21st century cannot be manufactured. Here's the dimension almost nobody in the Western press is discussing plainly. Taiwan's rainfall patterns are not becoming more stable. They are becoming less stable. The island's hydrology depends heavily on typhoon seasons that historically delivered reliable annual precipitation to reservoir systems built for a predictable climate. What climate scientists studying the Western Pacific have documented in peer-reviewed literature that TSMC's own sustainability reports quietly cite is that Taiwan is experiencing longer dry periods between precipitation events, even as total annual rainfall remains roughly constant. The reservoirs empty faster between storms. The ground cannot absorb and retain water at historical rates. The buffer between enough water and crisis is shrinking, not growing. The desalination plants TSMC has commissioned represent genuine investment. The company's recycling rates are genuinely impressive by industrial standards. But desalination at the scale required to substitute for reservoir failure is not yet operational. The plants currently in service provide partial backup. They do not provide full replacement. The gap between what desalination currently delivers and what a major drought would require is not a gap that closes in months. It closes in years, at best, assuming construction proceeds on schedule and the technology performs at design specifications in real operational conditions, neither of which is guaranteed. Now let's do the math, because the math is where this story becomes genuinely alarming. TSMC's total revenue in 2023 was approximately $69 billion. The advanced node fabs, the ones producing 3-nanometer and 5-nanometer chips, represent the highest margin, highest demand, most strategically irreplaceable portion of that output. A production disruption of 20% at TSMC's leading-edge facilities for a period of 30 days would remove from the global supply chain roughly $5 to $4 billion in chip output. That sounds manageable until you understand what those chips unlock downstream. One advanced processor chip, worth perhaps $400 at the fab, enables a data center server worth $30,000. That server supports cloud computing contracts worth hundreds of thousands of dollars annually. A 30-day disruption at the chip level does not produce $4 billion in lost economic activity. It produces a cascading shortage that within 90 to 120 days manifests as delayed product launches, elevated prices for consumer electronics, deferred AI infrastructure build-outs, and automotive production slowdowns, because modern vehicles require between 1,000 and 3,000 semiconductor chips each, and the just-in-time inventory systems auto manufacturers use leave essentially zero buffer. The ratio here matters. $4 billion in disrupted chip output triggers somewhere between $40 and $100 billion in downstream economic impact. Read that again. The multiplier is 10 to 20, 5 times. And this is not a theoretical model built by pessimists. It is the empirical record from 2021, documented in quarterly earnings reports from Ford, General Motors, Toyota, Apple, and dozens of other companies that spent a combined hundreds of billions of dollars in market capitalization absorbing a supply shock that originated, in significant part, in Taiwan's reservoir levels. Now pull back from the supply chain economics and look at the geopolitical chessboard, because what's happening with Taiwan's water is not happening in a vacuum. Beijing is watching this. Carefully, methodically, with the strategic patience that Washington's quarterly earnings-focused analysis consistently underestimates. China's military planners have studied TSMC's water dependency in detail. This is not speculation. It is documented in publicly available Chinese defense academic literature. The conclusion those planners have reached is one that changes the calculus around any scenario involving Taiwan. A conventional military operation against Taiwan would be enormously costly, strategically uncertain, and would trigger a Western response that Beijing currently prefers to avoid. But there is a slower, less visible form of pressure available. Climate stress on Taiwan's industrial infrastructure does Beijing's work without a single soldier crossing the strait. If Taiwan's semiconductor output becomes unreliable, not through military action, but through environmental fragility exposed by climate change, the argument for why we need Taiwan's chip capacity, protected at enormous cost and geopolitical risk, becomes harder to sustain in Washington boardrooms and congressional budget hearings. China is simultaneously pursuing its own semiconductor ambitions with a ferocity that the American press regularly covers but rarely contextualizes against Taiwan's vulnerability. SMIC, China's leading chipmaker, received an estimated $30 billion in state subsidies between 2020 and 2023. Chinese domestic chip production capacity is being built inland, away from coastal climate risks, with water recycling infrastructure designed from day one for arid region operation. Beijing is not building a semiconductor industry that depends on typhoon rainfall. It is building one engineered for supply security. That engineering choice is a strategic decision, not a technical one. Russia's posture in this picture is less direct, but worth naming. Every quarter in which Western attention is consumed by semiconductor supply anxiety, every boardroom conversation about where to source chips if Taiwan becomes unreliable, every billion-dollar investment in Arizona or Germany or Japan trying to replicate capabilities that took Taiwan 40 years to build, is a quarter in which the Western alliance's industrial coherence is being tested. Moscow gains passively from any fragmentation of the global technology supply chain. A world in which semiconductor access becomes a geopolitical variable rather than a market commodity is a world in which economic leverage redistributes away from the American-led order. That redistribution benefits Russia structurally, regardless of whether Russia lifts a finger. The Global South angle is equally significant and almost entirely absent from mainstream coverage. India, Brazil, Vietnam, Indonesia, the governments of these nations are watching Taiwan's water story and drawing conclusions about the reliability of the current global technology supply chain. Several of them are in active conversations with both Washington and Beijing about domestic semiconductor investment. The implicit message they have received from the 2021 shortage is that dependency on a single geography for critical technology inputs is a national security vulnerability. That message is accelerating diversification efforts that over a 10-year horizon will reshape the global semiconductor market in ways that TSMC's current dominance makes easy to underestimate today. Here's where this lands. Taiwan's drought vulnerability is not a peripheral footnote to the semiconductor story. It is a central, underweighted risk factor that the industry, the investment community, and the Western governments depending on Taiwan's output have systematically chosen not to price in, because pricing it in honestly would require confronting the degree to which the digital infrastructure of the modern world sits on a foundation that includes weather patterns over a subtropical island and the capacity of reservoir systems built in the 1970s. TSMC is a remarkable institution. Its engineering excellence is genuine, its investment in resilience is real, and its management understands the water problem better than almost any outside analyst. But institutional excellence cannot engineer away climate variability. It cannot build desalination capacity faster than droughts arrive. It cannot guarantee that the next severe drought, which climate models suggest is a matter of when, not if, will coincide with a year when emergency reserves are full and geopolitical circumstances are calm. Here are my 3 predictions, with timelines attached. Within 18 months, at least one major semiconductor analyst firm will formally reclassify Taiwan water risk from monitored concern to material operational risk in their coverage models. That reclassification will move capital. It will accelerate investment in TSMC's Arizona and Japan fabs in ways that the current timeline does not reflect. And it will cause the first serious public conversation about whether TSMC's leading-edge capacity needs geographic redundancy, not because of China, but because of rain. Within 3 years, a drought event in Taiwan, not necessarily as severe as 2021, but occurring when global chip inventory is lower and AI infrastructure demand is higher, will produce a supply disruption that makes the 2021 shortage look manageable. The downstream economic impact will be measured in hundreds of billions of dollars, and the political conversation that follows will finally loudly, include the word water. Within 5 years, the United States government will have spent more money trying to replicate TSMC's capabilities on American soil than it has spent on any industrial policy initiative since the space race. Most of that spending will produce facilities that are years behind TSMC's leading edge. The gap will narrow. It will not close. And the water risk in Taiwan will still be there, still underweighted, still one dry typhoon season away from becoming a crisis that no amount of domestic investment can absorb in real time. The question this story leaves open, and I want your answer in the comments, is this: do you think the Western response to Taiwan's semiconductor fragility is moving fast enough, or are we building the insurance policy after the house is already on fire? Tell me what you think. I read every single comment. If this gave you a framework for understanding the semiconductor story that goes beyond the trade war and the tariff headlines, a lens that connects climate, water, and the devices in your hands, share this with one person who needs to understand what's actually happening beneath the surface of the tech economy.